Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Our topic today is motion, position, and distance. What is motion? It's important to know that motion is defined as a change in position. So if an object started here and ended over there, we can say that the object moved. Today we're going to learn about defining and measuring an object's motion. Everything has to be someplace. You need to know that in physics, we refer to the location of an object as an object's position. So in other words, an object position is the location of an object at any given time. The symbol we use to represent position is a lowercase x. Think of it like a treasure map. X marks the spot. Now we're going to take a look at an air trolley, an object in motion. Now let's represent the motion we just saw from the air trolley. This line represents the air trolley line. If we want to represent the motion we just saw, we can use an air trolley and place it on the line. This is where the air trolley started. To mark it with a symbol, we can put an X above the air trolley. Now, we want to show that the object actually moved. So how are we going to show that the object moved? Well, one way to do it is to put another air trolley on the board to represent where it finished its motion. Again, that's its position, so I'm going to label it with an X. Now, does this represent the motion? Well, it looks like if somebody came in here and looked at the board, we have two air trolleys on one line because X marks both spots. Well, that's not exactly what we want to represent. We want to represent that this is where the air trolley started and that's where the air trolley finished. It is important to know these two terms. An object's starting position is called its initial position. An object's ending position is called its final position. To represent its starting position or its initial position, scientists use the symbol X with a subscript, which means it's written a little bit lower than the X, subscript I. So now we can say XI represents the initial position. Likewise, the final position is given the symbol X with a subscript, so it's written a little bit lower than the X with a subscript of F. That represents XF, or its final position. Now if you look at this, it represents the motion that we saw. We know that the object started here at its initial position, and it ended here at its final position. Now, what other information might be helpful to somebody in terms of representing the motion of the air trolley? Well, one other piece of information we could give is distance. Please write this down. Distance is defined as the amount of change of position. Distance is defined as the amount of change of position. So we can say that the object started here and ended here. And how far it traveled in between there is the object's distance. You also have to know that the symbol for distance is a lowercase d. Now we're going to try to calculate the distance traveled. And to do that, we are going to need a measuring tool. This number line is going to represent centimeters. Okay? Now before we can actually calculate how far the air trolley traveled, I want to also one more time, I want to remind you, this xi is the air trolley's starting position. xf represents its final position. In order to calculate distance of an object that's not a point or a dot, we're going to have to pick a reference point to use on the object. Please write this down. A reference point is a specific location on an object used to measure a change in position. A reference point is a specific location on an object used to measure a change in position. I'm going to pick a reference point and I'm going to indicate it using an arrow. It doesn't matter where on the object you pick as long as it's the same place on both the initial and the final position. So I'm going to use the propeller or the front of the air trolley. Okay, there it is. And I'm going to do the same thing and use an arrow to represent that on its final position. The front. Okay. Now I can actually measure the change of position. To calculate distance, we're going to use a formula. Please write this down. The formula for calculating distance is lowercase d equals xf, or the final position, minus the initial position, xi. You know what all these symbols mean, so to complete this, we just have to fill in the values. We're looking for the distance, the value for our final position, if you look at our number line, and if we use the front of the air trolley as our reference point, is 85 centimeters. We're going to subtract from that our initial position. Again, we use our reference point, the front of the air trolley, which is 10 centimeters. If we do that subtraction, the distance traveled by this air trolley is 75 centimeters. So that is how we can calculate the distance of an object. Let's review. Motion is a change in position. The position of an object is its location at any given time. And the symbol for position is lowercase x. The initial position is an object's starting position. Its symbol is x subscript I. And the final position is that object's ending position. Its symbol is x subscript f. Distance is the amount of change of position, and its symbol is lowercase d. Finally, to calculate distance of an object that's not a point, you need a reference point. And that is a specific location on the object that you use to measure. And that is the end of our motion, position, and distance module.